Good morning, students. My name is Abhishek Sachdeva. I am from Lalpur Khalsa College of Engineering, Department of Civil Engineering, and this is the lecture for Civil 4th semester class, and the subject is Concrete Technology. Students, we were discussing the mechanical properties of the concrete in our last two lectures. So, mechanical properties includes compressive strength test, split tensile strength test, and the third mechanical property is the flexural strength. So, compressive strength, split tensile strength, and flexural strength are considered as the mechanical properties of the concrete, and now, in this lecture, we will be discussing the flexural strength of concrete. So, talking about the flexural strength, it is also known as modulus of rupture, bend strength, or fracture strength. A mechanical parameter for a brittle material is defined as a material's ability to resist deformation under the loads. The flexural strength represents the highest stress explained within the material as its moment of rupture. So basically, the students talking about the flexural strength, it evaluates the tensile strength of concrete indirectly. If we are talking in the indirect manner, it is representing the tensile strength of the concrete, and they test the ability of unreinforced concrete beam or slab to withstand the failure in bending. So basically, this test provides us the ability of the unreinforced concrete beam or the slab to withstand the failure in bending. Students, when an object formed of a single material, like a wooden beam or a steel rod, is bent, it experiences a range of stresses across its depth. If we take an example of the beam, right, and we are pressing the load, we are applying the load over the beam, so it will be subjected to the bending. So students, you can observe the diagram which is on the top right corner. So when an object formed of a single material is bent, it experiences range of stresses. The stresses, they are basically, the section is experiencing the stresses across its complete depth. And when you will observe this, at the edges of the object on the inside of the bend, that is the concave case, the stresses will be at the maximum compressive value, and at the outside of the bend, the stresses will be at its minimum tensile value. Students, talking about this compressive value and the tensile values, you should remember this particular concept while talking about the flexural strength of the concrete, that at the edge, when the load it is applied, so the maximum compressive stress, the maximum compressive stress, it will be on the inside of the bend. When you are observing that diagram which is given on the top left right corner, the maximum compressive stress will be at the inside of the bend, and talking about the maximum tensile value, that will be on the outside of the bend, that is the convex phase. So this is the basically nature of the flexural strength. And next, these inner and the outer edges of the beam or rod are known as the extreme fibers. Outer and the inner edges of that section on which the load is applied and the stresses are generated to the complete depth, at the edges they are known as the extreme fibers. And most materials fail under the tensile stress before they fail under the compressive stresses. So the maximum tensile stress value can be sustained sustained before the beam or the rod fails in its flexural strength. So the results of the flexural test on concrete, they are expressed as the modulus of rupture, which denotes the MR, that is the modulus of rupture in MPa, that is Newton per mm square. The flexural test on the concrete can be conducted using either 3-point load test ASTM C78, that is the code which is referring the 3-point load test for the flexural test, or center point load test ASTM C293, the code referring the central point load test in case of the flexural strength test. So the configuration of these loading conditions that I'll explain you later. Students, apparatus required. What are the apparatus required for the basically performing this test? So talking about the apparatus, obviously we should have the compressive flexural strength testing machine. Flexural strength testing machine is also similar to that of the compression testing machine. Basically, we are keeping the specimen which is of the beam, which is of the shape of the beam. So we are placing that specimen in the compression testing machine, and we are basically applying the load. So that basically, if we are talking about the flexural strength arrangement, it can be the central point or the 3-point loading, and the arrangement is in such a manner that we are applying the load, and the reading it is being obtained by the gauges of the machine, or it can be obtained electronically. So this is the flexural strength testing machine, or we can obtain it as the universal testing machine also. Students, in our institute, we are having the flexural strength testing machine, which is attached to the compressive strength testing machine. Samples, they are not tested in the compressive strength testing machine directly, but the arrangement is attached in such a manner that when you are placing the specimen in the flexural strength testing machine, the gauges which are used for the compression testing machine, the dial gauge, the loading conditions which are associated with the compression testing machine, and the output which we are getting electronically, output which we are getting digitally, that is being associated with the compression testing machine. But the loading conditions, the conditions under which the beam is tested, the condition under which the loading is being placed over that section, the particular beam, that is kept in the flexural testing machine, and the test is performed in that flexural strength testing machine or the universal testing machine. So depending upon the type of the machinery, the manufacturing, the company, the capability of the machine may vary from category to category. Then if we are talking about the other apparatuses or the equipments which are used for the flexural strength test, they are the steel or the iron cast or other non-absorbent material molds having the size of 150 mm by 150 mm by 750 mm. So size of molds. Then tamping rod is required, 16 mm in diameter and 600 mm in length. Testing machine, right? And the scoop, the trowels, the balance with accuracy of 1 kg, the concrete mixture or the vibrating plates for vibrations if we are not using the tamping rod, right? So these are certain apparatus which are required. So flexural strength of the specimen expressed as the modulus of rupture, that is your flexural strength equal to P into L by BD square. So basically P, it is the applied load in kgs which will be applied on the section, and multiplied by the L, which is the length of the span on which the specimen was spotted, divided by B into D is the measured width of the specimen, and D is the depth of the specimen at the point of failure in centimeter, right? So students, kg per centimeter square is the formula. You can observe this diagram, the specimen, the beam section, it is placed in the testing machine, and marking is done over the beam, and when the loading is applied, so it is failing. So the rupture, the failure, how the beam has failed under this particular specific condition, you can see this diagram also. Now students, loading types. As I have explained you, the value of modulus of rupture, that is extreme fiber stresses in bending. It depends upon the dimension of the beam and the manner of the loading. Dimension of the beam is specific, and talking about the manner of loading, the system of loading used in finding out the flexural tension are central point loading and third point loading. In central point loading, maximum fiber stresses will come below the point of loading where the bending moment is maximum. And in case of the symmetrical two-point loading, the critical cracks may appear at the any section not strong enough to resist the stresses. And in case, it can be expected that the two-point loading will yield a lower value of modulus of rupture than the center point loading. So students, depending upon the loading condition, the beam will be subjected to the failure. In case symmetrical two-point loading, the critical crack may appear at any section, right? Not strong enough to resist the stresses within the middle third. So as per the conditions of the loadings, when the sample is placed in the flexural testing machine and it will be subjected to the loading condition, so as per the loading condition, failure will occur. And how the failure will occur, you can observe this diagram. Loading condition, right? 3 point and 4 point. And when we are talking about the 3 point, three conditions, the loading conditions, you observe this: centrally loaded and two supported over below the section which will be supporting pins and pushing the stresses upwards, and this will be stressing downwards. So this is the 3 point flexure test. And 4 point, you can observe this loading pins, right, which are on the center of the section, and two supporting pins. So loading pins and supporting pins, this is the 4 point arrangement. And failure will be depending upon the type of the loading conditions which is subjected with the which your beam section is subjected to. So students, if we are talking about the sampling, right? If we are talking about the sampling of of preparing this particular molds for this flexural strength test, sampling procedure will remain same as we have discussed in the compressive strength test, as we have discussed in the split tensile strength test. So in this particular flexural strength test, the beams are casted, right? Beam sections are casted and concrete is produced as in the same manner we have discussed in the previous tests, and the specimen molds, they are filled up with the concrete, and the specimens, they are cured and tested after 7 days or 28 days of the curing age. And students, procedure which is included in this flexural strength of concrete. The test should be conducted, the important major points which are kept in mind, that is, the test should be conducted on the specimen immediately after taken out from the curing condition so as to prevent surface drying which decline flexural strength. The specimen, it is placed on the loading points. The hand finished surface of the specimen should not be in contact with the loading points. This will ensure an acceptable contact between the specimen and the loading points. This center the loading system in relation to the applied force. Then test, the dimensions of each specimen shall be noted before testing. No preparation of the surface is required. So whenever we are taking out the sample from the curing time, it is kept in the machine for testing. Then loading is applied. Loading is applied, applying loads between 2 to 6% of the computed ultimate load, employing 0.10 mm and 0.38 mm leaf type filler gauges. Specify whether any space between the specimen and the load applying or support blocks is greater or less than each of the gauges over the length of 25 mm or more. Marking is done on the specimen. The specimen shall be then placed in the machine in such a manner that the load shall be applied to uppermost surface as cast in the mold along two lines spaced 20 or 13.3 centimeter apart. The axis of the specimen shall carefully aligned with the axis of the loading device. Then load the specimen continuously without shock till the point of failure at the constant rate. As per the Indian standard, the constant rate of loading of 400 kg per minute for 150 specimen and 180 kg per minute for 100 specimen that is required. So load the specimen continuously. Then then the load, it will be increased until the specimen failed, and the maximum load applied to the specimen during the test was recorded will be recorded. So maximum load, the load, it will be increased, and the maximum load applied to the specimen, that will be recorded. The appearance of the fractured faces of the concrete and any unusual feature in the type of failure will also be noted. The flexural strength of the specimen, it will be expressed as the modulus of rupture, and the formula for that is FD, that is the flexural strength, equal to E into L upon B into D square. This expression I have already explained you. If the fracture initiates in the tension surface within the middle third of the span length, then the expression will be 3p into A divided by B into D square. So this is the expression. And if the fracture occurs in the tension surface outside the middle third of the span length, we have to observe the fracture. We have to observe this fracture, and if the fracture occurs in tension surface outside the middle third of the span length by not more than 5% of the span length, and discard the result if it is more than 5%. So this is basically the observation of the fracture, and as the fracture will be observed, the values will be noted accordingly, and that values it will be applied in the expressions, and we will be getting the modulus of rupture. So students, this is all for the flexural strength test. Thank you.